The work rate formula can also be used when you have two objects or people working against each other. Here's an interesting example. A small leak, say, will fill an empty boat in 5 hours. What I mean by that is that it's a leak in the bottom of the boat and the boat is slowly filling with water. So what I'm saying here is that the leak is going to fill the empty boat in 5 hours. Now, of course, this is not something you want. The boat's bilge pump will empty a full boat in 3 hours. So the pump will empty that water that's in the boat if it's full in 3 hours. So the leak is going to fill an empty boat in 5 hours. The pump is going to empty a full boat in 3 hours. So they're working against each other. If the boat is half full of water and leaking, how long will it take the bilge pump to empty the boat? So notice it's half full of water. This is something a little bit different. That means they need to get half the job done instead of the full job. So remember how we had that one part of the formula, one way of writing the formula, where you had to do with the full job, where you had T over A plus T over B equals one full job. One of the things that would be good in this example is that we want to do half the job. So if we convert this formula to T over A plus T over B equals 1/2, we are in better shape, okay? Because this is half the job, basically half the boat. The other alteration we need to make is that these two things are working against each other. So that means that you need to, instead of adding the work they do together, you need to subtract the work they do together. Okay, and the one you're going to subtract is the one that is working slower. So in this case, the leak is the slower thing. So a small leak is going to fill an empty boat in 5 hours. So that means that we need to think about this second fraction as being T over 5. Now, we don't have to worry about changing the 5 because we've already got this 1/2. We're only talking about getting half the job done. Okay, and this 1/2 is going to take into account that we're only doing half the job. Now, the pump is going to empty the full boat in 3 hours. So that would be writing as the first fraction T over 3. Okay, so we end up with an adjustment of the formula to not only take into account the fact that these two things are working against each other by using subtraction and subtracting the one that takes longer to get stuff done, the term that involves that. And then we also need to adjust that we're only doing half the job. We're only talking about the boat being half full or half empty, depending on the way you want to think about it. So we end up with this equation from an altered version of the work rate formula. To solve this, we're going to get a common denominator. The number that all three of these numbers go into, 3, 5, and 2, the smallest number would be 30. So the LCD is 30. And we're going to multiply every term by 30 over 1. All right, clear or cancel the denominators. 3 goes into 30 10 times, 5 goes into 30 6 times, 2 goes into 30 15 times. So what I get in the end when I clear fractions is 10t, so I didn't change colors there, 10t minus 6t equals 15. So that's 4t equals 15, and therefore t is equal to 15/4. Or if we make that into a mixed number, that would be 3 3/4 of an hour. So it turns out that the pump is going to empty the boat, even while the leak is still there, in 3 3/4 hours, because the pump is working faster than the leak. Write that out in words. The pump will empty the boat in 3 3/4 hours.